Welcome to Manufacturing Talks with Jim Vinoski. Industry has a million cool stories, and Jim talks to the movers and shakers who are making them happen. Let's dive in.
All right, welcome back to Manufacturing Talks. I'm Jim Vinoski, your host. We are broadcasting live from Detroit, from the American Gear Manufacturers Association Motion and Power Technology Expo at Huntington Place. And I'm joined right now by John Perrotti. He is the CEO of Gleason Corporation. Welcome, John.
Hello, Jim.
Thanks for being here.
It's my pleasure.
John is all the way from out in upstate New York, from Rochester, not too far from where I used to live in Buffalo. So you had to travel a little more than I did to get here.
Yeah, but it's drivable, actually.
Okay.
It's not too bad.
Good. Well, I'm glad you made it safe. And, I've talked to a bunch of people today, but, like really manufacturing in general, most of the people I've talked to so far are from small companies, and you're not.
Well, compared to some companies, we'd still be considered small.
Arguably,
But within the gear industry, particularly gear technology providers, we're actually a fairly large company.
Yeah, and we'll dive into all the different things that Gleason has going on. But before we do that, why don't you just tell us a little bit about yourself, your background, how you got into being the CEO of Gleason?
Well, it wasn't really by plan, but so I've been with Gleason for 37 years.
Wow, nice.
I always joke that I started when I was 8 years old. But, people look at me and they don't believe that. But,
I do, John.
Thank you. It must be the lighting. But, I actually, and I've been CEO since 2005. So I tell folks, as proud as I am of 37 years, actually being CEO for 18 years probably has defied the odds even more.
Yeah.
CEO's shelf life is oftentimes less than that.
That is true.
But
you must be doing okay then.
Well, I'm trying.
Right.
It takes a village, as they say.
Yes. Yep.
But, I actually started off more with a business and finance. And while I was at Gleason, I became chief financial officer. But Jim Gleason, who's the great grandson of the founder, and Jim passed away last year. But Jim had the foresight or the confidence that he actually gave me the opportunity to also run our Rochester operation, which at that point in time had maybe 1,300 people. And I was 35 years old at the time.
No, wow. Yeah.
And so that was a big orientation for me, where it helped me balance both my finance and business skills with operations, and through a lot of osmosis, learning a lot about gears, our products, global markets, and those things led to becoming CEO. And 18 years later, I still can't find anybody who wants the job. So.
Right. Yeah. Well, good for you. So there's a bunch of different pieces of Gleason. Tell us, where did the company come from? How did it grow into what it is today?
Well, the company is 158 years old. Mm-hmm. Founded in 1865. I always joke with folks, 1865 is a sort of special year in American history, if you're a history buff.
Yep.
So that was, the Civil War ended, and
right.
About a week later, Lincoln was assassinated, and then right after that, Gleason was founded. So
yep.
3 key events in American history. Yeah. You can decide what order you want to put them.
The ranking.
The Gleason history books have their own version.
Yes, I'm sure.
But William Gleason, who was the founder of the company, came over from Ireland during the potato family
Oh,
in the 1840s as a young lad, as they would say, and got involved in metalworking and formed a series of companies, including with partners, and then really in 1865 ventured on his own. Had his first patent related to gears in 1874, and the company's, for much of its history, was known for bevel gears. Bevel gears are gears that are used to take power around a corner. Right angle gearboxes, things of that nature, rear wheel drive vehicles, the north-south engine orientation, taking power around the wheels.
Yep.
And many people around the world still call bevel gears Gleason gears,
Oh,
because
yeah.
Gleason invented much of the science around bevel gears, which are rather complex in terms of their geometry and meshing characteristics. But that's a lot of what the company had done and how it had grown up. Interesting story is the son of William Gleason, James E. Gleason, started working for the company in 1884, and 80 years later died in his office in 1960.
Wow.
So 80 years of service, and you can only imagine what that's like, going from working for a company in 1884. There was no such thing as an automobile,
Right.
and to 1964, where Gleason was making gears supporting the space program.
Yeah, that's amazing. So came out of the gear world. I'm looking at the website here, but now you guys are into all kinds of things. So you do design work, you do machinery, you do metrology. How does all that add up together? You know, a lot to manage.
Well, it is, and that's been what our strategy is. We hold ourselves out as the largest provider of gear technology solutions, which includes advanced manufacturing solutions, but it also includes design and measurement. So we're really trying to cover the whole value chain, from design, manufacture, measurement, that closed loop, all the connectivity between them.
Yep.
And that's really our strategy, and that's what our product portfolio represents.
Yep. Yeah, and it's amazing to look at the breadth of what you do, and it is all focused around the origin of the company, but all the different aspects, right? Cover pretty much everything under the sun when it comes to gear.
Yeah, today we're the largest because we have the broadest product portfolio.
Yeah.
From design, within manufacturing, we have machines that produce all types of gears: spur, helical, worm, bevel, double helical, all types of gears of all sizes.
Right.
We have a plastic gear division,
Yeah, I saw it on here too.
that in this case we're making the gears, but that are so small you need magnification to be able to see the teeth of the gears, up to gears that are 10 meters in diameter on certain machines that are used for heavy industrial gearboxes.
Yep. Yeah, move this a little closer to you.
So
Yeah.
yeah, so it's everything under the sun is what we do, and all the tooling that goes with it.
Yep.
So that means the custom-made work holding to hold the work pieces, the cutting tools to do the metal removal, automation systems. Today I tell people we don't sell machines, we sell systems,
Right. Yep.
and hopefully intelligent systems. So this is our product portfolio and how we define ourselves.
Yep. So with that breadth, I have to imagine your strategy here at the show is probably a little different from what a lot of people are. You have to be touching every segment of the business that's represented here.
Yeah, there's not much that when it comes to gearing, that we're not involved in.
Yep.
And so anybody who's involved in gearing or power transmission, there's a good chance that we have a product or solution that might be of interest to them.
Yep. So what are the big highlights for the week for you? What are the things that you really focused on?
Well, a couple of things that we're focused on and talking about a lot at the show here is electrification.
Oh, yeah.
So electric vehicles. We have a lot of interesting solutions for that market. Obviously, for the automotive industry, it's a once in a century kind of transformation that they're going through. The gearing requirements for electric vehicles are quite different than they are for the internal combustion engine. Fewer gears, but the gears are of much higher precision.
Yep.
And what's called the NVH, noise, vibration, harshness characteristics are much stricter because you don't have the internal combustion engine masking some of the noise.
Right. Yep.
The tolerances on these gears are very tight. And so one of the things we're presenting here this week is our what we call our GRSL machine, gear rolling system with laser, that actually allows the in-process inspection of gears. Historically, most gears have had inspection machines like coordinate measurement type machines, tactile measurement with a probe, that would sit in a temperature controlled lab, typically many yards or meters away from the production area.
Mm-hmm.
And when somebody would run a first piece in a lot, could be a lot of several hundred parts, they'd go take apart and inspect it, and maybe do some corrections. And the inspection wouldn't even be of all the gear teeth.
Yeah.
You know, they touch points on 4 gear teeth, do some statistical averaging to determine if that was or was not a good gear and what, if any, corrections or adjustments needed to be made. And then they might inspect another part 300, 400, 500 parts later.
Yep.
With the quality requirements for electric vehicles, it's almost requiring 100% inspection of all teeth.
Yep.
So think about how you have to make that jump. And so this GRSL is a laser-based solution where generally within the takt time of the manufacturing process, you know, you're able to inspect these parts, all teeth.
Yeah.
So it's a quantum leap from historically how gears have been measured.
Right.
And what this gives you is not just, is it a good gear or a bad gear? Is it good or a reject? But it gives you massive amounts of data real time, a dense point cloud of data real time. You can imagine collecting from that laser.
Yep.
Plus, combined with the machine information, process data you're collecting from the machine about machine vibration, machine temperature, motor draw on the machine, all kinds of process data on the machine, where in real time you're able to look at the machine data and the inspection data to do real-time problem solving and optimization. And again, this is a revolutionary leap where gear processing has been for years.
Well, it's intriguing to me because in earlier conversations, we certainly touched on some of the technology development around gear making itself, metallurgy, things like that. And you really focused on the gears, and we never really talked about there's all these other elements that are also progressing. Metrology, you guys do software as well. So it's fascinating to me to just hear how there's those pieces that no one ever thinks of that are all covered here under one roof.
Well, and the connectivity between these, where today we're able now to take the results from the metrology machine, and without an engineer setting in some cases, rather arbitrary limits as to whether that's good or bad. That has to be within this, that has to be within that.
Yep.
Oftentimes with a lot of safety factors built in because they don't really know.
Yep.
Today, you're able to take those results and you're able to run it back through our design and analysis software
Mm-hmm.
and understand all of the variables, how when integrated together
Right.
in a more cumulative sense, what is that relative to a gear set and its rolling characteristics and contact pattern and so forth. And again, so it's not just to have design, manufacturing, metrology, but it's the synthesis of all these things together,
Mm-hmm. Yeah.
which I think is sort of the exponential effect.
Yeah. And that element that is being driven by these much greater needs for our current technology as they progress.
Like I described to another group earlier today, it's better than aerospace quality, but in mass production
Mm-hmm.
is what some of these demands within the electric vehicles are. Some people are starting to believe that electric vehicles don't have gears.
Matt and I covered that. Yeah.
And not only do they have gears, but gears are a very vital part of
Absolutely.
electric vehicles,
Yep.
and the demands are sky high.
Yep. Well, it's funny because when I first came across the AGMA, it was, I think I happened across someone on LinkedIn who was tied to it, and I thought, well, I write about manufacturing. I'm a mechanical engineer by degree. I need to know more about these guys. So I got in touch and dug in and said, this could be a Forbes article, this could be a show. It actually wound up being both. I wrote a Forbes article. I had Matt on my show back about 6 months ago. And that was one of the main elements of our discussions early on is, people think gears are going away. They just couldn't be more wrong.
Gears are still an extraordinarily efficient way to control speed and torque.
Yep.
And of course, as gears are made more accurately and more cost effectively, that makes them all the more valuable.
Right.
And hard to displace.
Right. Opens up new opportunities for other applications.
Yeah. And so even though electric vehicles may have fewer gears in them than, say, an 8 or 9 speed automatic transmission,
Yep.
the demands for those gears are higher.
Yep.
In some cases, the processing is more intense.
Right.
But even the number of gears there is multiplying because you don't just have an electric motor on one axle. Now you have it on 2 axles in most cases.
Yep.
Double the number of gears.
Yep.
Some are even now going from 1-stage designs to 2-stage designs.
Right.
Some are going to planetary gear systems, which have a higher number of gears in them.
Yep.
Not to mention all the other gears that are in vehicles besides the transmission-related
Mm-hmm.
gears.
Yep.
Our plastic gear business, for example,
Right.
not
Yep.
just focused on steel gears, but everything that moves on a car, whether it be the side mirrors, the tailgate,
Yeah. All
the
the stuff,
lights.
all the stuff that's automated now that we used to have to do by hand.
Power seats,
Yeah,
all
yeah.
of these things have gearing in them.
Right.
Even on electric vehicles, they have much more temperature control systems on them
Right.
because of the battery and these things.
Yep.
Even gears involved in those temperature control systems and opening and closing valves and things.
Yep.
People have no concept of every place a gear is actually appearing.
Yep. Well, that's what we're partially here for, is to help educate people. And, there are all the applications beyond what we've talked about as well. I had 2 ladies on from IMT Forge, and they were talking about they've got a number of customers in the mining industry. And people realize we have to do a heck of a lot more mining to fulfill our goals.
One of our big industries is renewable energy,
Yeah. Oh, yeah.
particularly wind power.
Oh, yeah.
we have a huge backlog of orders for machines tied to the wind power industry.
Sure. Yep.
You know, those wind turbines have a lot of gears in them.
Oh yeah.
Both in the main nacelle, where they have multi-stage gearboxes, plus gears that are moving the blades themselves. So some of those gears in the nacelles, particularly for some of the offshore, they can be you know, close to 4 meters in diameter.
Wow. Yep.
So even solar panels
Oh, really?
use gears when they're sitting, when they have to rotate or move. There's gear-driven mechanisms.
Yeah. Think about that. Sure. Makes sense. That being said, obviously, Gleason has your fingers in a lot of different pies, and you've got a really good read on what's hot in the industry. Are there things you're looking at coming down the pike that haven't hit us yet that are opportunities, or alternatively things people need to be aware of and watching out for?
Well, I think some of the opportunities are, I'll use the broad word automation.
Mm-hmm.
And I don't mean automation solely in the sense of a robot or a conveyor,
Right.
although there's that market that continues to grow. But
Yep.
automation, as you mentioned earlier, almost in everything we do, what we used to do with our hands, is being replaced by some type of electromechanical device.
Right.
And in many of those electromechanical devices are gears
Yep.
between the input and the output,
Yep.
between the motor and the output. And that's continuing to grow.
Right.
And so where that goes and what other industries, it's amazing.
Yeah.
You know, the chairs that go up and down, the desks that go up and down.
Yeah, that's right.
You know, everything's connected to a switch and you know, and a piece of software and hopefully intelligent software that is driving it.
Yep.
So,
Yep.
and as I said, even in our plastic gear division, you know, we're doing things for faucets, and you know, there's even automation being brought to faucets turning
right.
automatically on and off, and,
Sure.
and
Yep.
having sensors and things that we would have never thought about 10, 20 years ago.
Yeah. Amazing. Everyone pretty much here has talked about the workforce challenges. I assume you guys are experiencing some of that. Are there things that you have going on to help alleviate that?
Well, we're a global company. We have employees in 20 countries around the world. So it's a little bit of a different story depending on what country.
Right.
Unfortunately, in the United States, I would say is where we're facing even some of our most severe labor constraints.
Okay.
Not just in terms of quantity, but also quality.
Yep.
As you might imagine, a company like Gleason really requires skilled labor.
Certainly.
We're even happy to put the training in. In many of our locations, we have apprentice programs. Or we work with local high schools or local community colleges, vocational schools. But it was hard before the pandemic, and it seems twice as hard after the pandemic.
Right.
The interest in manufacturing, I would say globally, but particularly in the United States, is tough.
Yep.
I'm hearing some stories that are giving me a little bit of hope about, you know, when I was growing up, it was like, you know, go to college, that's how you become a success.
Yep.
But I'm hearing some stories now about some of the graduating classes where fewer of the graduates feel the need to go to college, or maybe they'll go to college later.
Right.
And they believe that they can make you know, a good living with a trade, working with their hands. And working with their hands means not just getting dirty, but with a computer usually assisting.
Yeah, exactly.
And so that's encouraging. So I hope that continues to build. But in the U.S., we are continuing to struggle to find labor, retain labor. I really hope right from the beginning in the education side that we can find a way in this country to, I'll use the word glorify manufacturing, not just make it be political rhetoric.
Yeah.
Because we're not really seeing a manufacturing renaissance that people like to talk about.
No,
we're not,
I agree.
We're not really seeing the reshoring. And even when we do, and politicians stand proudly in a new factory, that's great. There's a new factory. But you look behind them, and typically what you'll see is a series of machines that are not made in the United States.
Right.
So it's good. You're hiring some people, but the technology really isn't the U.S. technology. And so my view of a manufacturing renaissance is when the technology you use to manufacture is again made in the USA.
Yep.
In the 1980s, the United States was the largest producer of machine tools, metalworking machinery, advanced metalworking machinery. Number one producer. We're barely in the top 10 now.
Yep. Wow.
And machine tools are a good indicator of manufacturing technology.
Yeah.
So that's really what our government needs to focus on, and companies like Gleason that are exporters.
Mm-hmm.
Half, 65% of what we make, we export.
Yep.
Advanced manufacturing technology. Those are the kinds of things our government needs to try to think about. How do we help them?
Yep.
Not focus on protectionist
Right.
policies regarding imports. Focus on those capable companies that today are exporting and could even potentially grow more.
Right. Yep.
I'll get off my political soapbox.
No, that's a great way to wrap things up. We're just about out of time. Is there anything we haven't touched on that you want to?
Well, 100 more things, but tune in later for it. No.
Absolutely. No, I agree 100%. I think especially that point about this touted renaissance, it's really not there. Unfortunately, it's a lot of government spending on things that are just going to, in a lot of ways, fall flat. And I think you're spot on. We need to be focused on companies like yours that are doing the things that work and talking.
Yeah. How do we grow our exports rather than how do we build walls against imports?
Yeah.
Play offense, not defense.
Yeah, absolutely. Well, John, it was wonderful having you here.
Jim, it's my pleasure. Thank you.
Thank you. And of course, thanks to our audience. We will be back very shortly. I've got a couple more sessions yet today here from the American Gear Manufacturers Association Motion and Power Technology Expo in Detroit. Come back in just a few minutes. We'll be back on. Thank you.
Thanks for tuning in to Manufacturing Talks with Jim Vanoski. Watch for new episodes dropping every Tuesday. And don't forget to like, share, comment, and subscribe.